Good day! By the way, I'm Faith Abigail Kapuso Yuson, first year, taking up Bachelor of Science in Agriculture, major in Animal Science. So for today's video, we will going to explain with my partner regarding AG104 Lesson 2 Learning Activity. My partner Danny will explain problem 1.1, 1.2, and 1.6, and the rest of it will be mine. So let's go for Danny's vid.
Hello everyone, my name is Danny Dagway and my partner Yuson Fit Abigail. I am first year college BSc Agriculture major in Animal Science. Now I will going to discuss all about lesson 2 learning activity and performance task. 1.1. Okay, 1.1. Now how many electrons does each of the following elements have in its outermost electron shell? Okay, we have potassium, calcium, and aluminum. So we start potassium. Okay, so you have to give the balance electron by drawing the bar model. This bar model of atom. So in order to know how many electrons to have to draw in your bar model, okay, you find the atomic number, okay, which is 19. So your atomic number of potassium is 19, okay. Therefore you need to plot 19 electrons in your bar model, okay. So in the first ring, the maximum of electrons is 2 electrons only, so that the atomic number is 19. So you need to put 2 electrons in the first ring, okay. 1, 2. So because your atomic number is 19, 2 minus 19, so equals 18. So you need to draw the second ring. Okay. Remember that the second ring is all maximum of 8 electrons only. Okay. So you have to put 8 electrons in the second ring. So 1, 2, 3, 4, 5, 6, 7. Oh, no, sorry. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2 equals 10. So you have 19 atomic number. So you have 9 electrons left. Okay. So you need to draw the third ring. Okay. So you put 8 electrons in the third ring. Okay. So 10 electrons plus 8 electrons, you have 1 electrons left. So your the second and the fourth, I don't know, the fourth ring hold maximum of 1 electrons. So your outermost shell is 1. So your balance electrons is 1. Okay. Okay. We have here calcium, the atomic number of 20. Okay. That means we have to put 20 electrons in the orbital rings using the model atom. Okay. So we draw the element symbols, and remember the center is the element symbols Ce. Okay, Ce is represent of calcium. Okay, now you can put 2 electrons in the first ring because the atomic number of calcium is 20. Okay, you can put 2 electrons in the first ring. Okay, the first ring contains 2 electrons. Okay, and then 20 minus 2 was 18. Make sure you distribute equal so. Okay, so that means 20 minus 2 plus 18. That means we need to put others electrons. So 20 minus 2 equals 18. Okay, we need to draw another ring, second ring. Okay, and remember the second ring can hold maximum of 8 electrons only. Okay, but we are aware that the center is the protons and the neutrons. Okay, okay, and then because of the 20 atomic number of calcium is 20, we need to draw the third ring. The third ring is the same of the second ring, contains of 8 electrons only. Okay, and the fourth ring is contain of 2 electrons, and then the electrons, the outermost electron shell is 2 electrons in the calcium hub in the outermost electron shell. Okay, and then we proceed ground state electron. Okay, here, then I will see you how to get ground state electron configuration. Okay, here, okay, 1s, okay, 1s, 2s, 2p, 3s, 3p, 4s. Okay, so it's here, 1 is 2, 2 is 2, 2p6, 3 is 2, 3p6, and 4 is 2. Okay, so 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus 2 equals 20. That's a atomic number of calcium. Okay, let's continue. You have here aluminum. Aluminum has atomic number of 13. Okay, and that means we have to put here 13 electrons in the orbital rings, the same of calcium. Okay, so we draw the element of symbols. Okay, so now we can put the electrons in the first ring. You can put 2 rings 2 electrons on the first ring, okay? So 13 minus 2 equals 11, okay? So because your atomic number is 13, okay? So we need to draw another ring in the second ring, okay? In the second ring contains of 8 electrons, okay? So the second ring contains 8 electrons, then the first ring contains 2 electrons, right? So 2 plus 8 equals 10, okay? And then you need to draw the third ring because your atomic number is 13, okay? So your the outermost is contains of 3 electrons, okay? So there are 3 electrons that aluminum have in its outermost electron shell, okay? This, okay. So how to get the configuration in this, okay? Okay. So we have 1 is 2, sorry, 1 is 2, 2 is 2, 2 is 6, 3 is 2, 3p, okay? Then, no, 2 plus 2, 4 plus 6, 10 plus 2, plus 2, 12 plus 1 equals 13, okay? So the atomic mass of aluminum is 13, okay? Okay, let's move to problem 1.2. Give the ground state electron configuration of following elements. Okay, the first is boron. The atomic number is 5. So ground state electron configuration is 1 is 2, 2 is 2, 2p1. So add 1 is 2 plus 2 equals 4 plus 1 equals 5. So the atomic number of boron is 5. This is the solution. Okay, then second is phosphorus. Atomic number is 15. So the ground state electron configuration is 1 is 2, 2 is 2, 2 is 6, 3 is 2, 3p2, 4 1, 4 is 2, 4 is 1, sorry. So add 2 plus 2, 4 plus 16 plus 2, 12 plus 2, 14 plus 1 equals 15. So the phosphorus atomic number is 15. This is a tertiary configuration. Okay. And the third is oxygen. Atomic number is 8. So electron configuration is 1 is 2, 2 is 2, 2p4. So add 2 plus 2, 4 plus 4 equals 8. So the atomic number of oxygen is 8. And this is a solution. Okay. And the last is argon. The atomic number is 18. So electron configuration is 1 is 2, 2 is 2, 2p6, 3 is 2, 8, 3p6. So add 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18. So the atomic number of argon is 18. Okay. This is the solution. Okay. 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 Okay, let's continue our discussion. Problem 1.6. Question is, write both electron that unline band structure for the following molecules showing on unbanded electrons. Okay, we have CH3Cl3 chloroform. So carbon has 4 valence electron, hydrogen has 1 valence electron, and fluorine has 7 valence electron, and fluorine is 3. Okay, 3. So for structure, hydrogen always going outside. Okay, you can put carbon in the center and hydrogen in the inside, outside, and then fluorine on the other side. Okay, so when you look at fluorine and you look at carbon in the center, that's the electronegative. Okay, so we have 26 valence electron of CH3Cl3. Okay, we put to that between atom for valence electron. Okay, so to that plus 2, 4, 6, 8, 10, 12, 13, 16, 18, 20, 22, 24, 26. Okay, so that's a CH3Cl3 color form. This is a structure. Okay, let's proceed. We have hydrogen. Okay, H2 is hydrogen sulfide. Okay, so hydrogen has 1 valence electron and sulfide has 6 valence of electron. Okay, so 2 hydrogen, okay, is combined one valence of electron. Okay, and combined with sulfide 6 electrons. Excuse me, if electrons and the total of Lewis structure is, I'm going to put sulfide at the center. Okay, at the center, and the surround is hydrogen. Okay, need to put that. Okay, 1 2 3 4 6 8. Oh, sorry, 2 4 6 8. Okay, 6. Okay, 6 electrons of sulfide. Okay, then 2 valence of electron in other side. Okay, thank you. Okay, so let's continue our discussion. We have CH3 and H2 methylamine. Okay, so we have carbon in the center. So that one carbon and the 3 valence of hydrogen, and then 1 nitrogen and the 2 valence of hydrogen. So you can count of the balance: 1 2 3 4 5 6. So 5 times 2, excuse me, sorry, 6 times 2 equals 12. So 2 left. So we need to put 2 dots in here. Okay, so 12 plus 2 equals 15. So that is the lowest structure of methylamine is 14. Okay, thank you.
Wow, well explained, Danny. For now, it's my turn. Let's start with problem 1.7. The question is, Why can't an organic molecule have the formula C2H7? Organic molecule can have the formula C2H7 since carbon has 4 valence electrons and one of the valence electrons is form carbon-carbon single bond, which means that there are 3 remaining valence electrons left in every carbon atom. And the remaining 3 valence electrons will make use by the hydrogen. As you can see in the given example. So let's move on to problem 1.16. The question is, which element in each of the following pairs is more electronegative? So let's start with letter A, which contains the 2 elements, lithium and the hydrogen. So in able for us to determine which of the 2 elements is more electronegative, we have to use this table. So as you can see in the table, has an electronegativity value of 1.0, while hydrogen has 2.1 electronegativity value. So it's obvious that hydrogen is more electronegative than lithium. Let's move on to letter B. The elements that we have to look for its electronegativity value is the beryllium and the bromine. We have to use this table again. So as you can see in the table, beryllium has an electronegativity of 1.6, while bromine has 2.8. Therefore, bromine is more electronegative than beryllium. Letter C, which contains 2 elements and iodine. So we have to use this again. We have to look for the electronegativity of the chlorine. So chlorine has an electronegativity value of 3.0 and iodine has 2.5. So therefore, the element that is more electronegative is the chlorine. Problem 1.17. The question is, use the partial positive and partial negative convention to indicate the direction of expected polarity for each of the bonds shown. So as you can see, there are 1, 2, 3, 4, 5, 6 bonds in problem 1.7. So in letter A, carbon and bromine are the elements that we're going to find its electronegativity. We're going to use this table again. So carbon and bromine. Carbon has an electronegativity value of 2.5, while bromine is 2.8. So our answer is carbon is partial positive while bromine is partial negative. Let's go to letter B. The element that we're going to find its electronegativity value is the carbon and the nitrogen. So carbon has 2.5 electronegativity value while nitrogen is 3.0. So therefore, carbon is partial positive while nitrogen is partial negative. Letter C. The nitrogen and the hydrogen. As you can see here in the table, nitrogen has an electronegativity value of 3.0 while hydrogen has 2.1. So our answer is nitrogen is partial negative while hydrogen is partial positive. Letter D. The elements are the carbon and sulfur. So carbon again has 2.5 while sulfur has 2.5. So therefore, carbon is partial positive and sulfur is partial positive too. They are just the same. So let's go to letter E. Carbon again and magnesium. So carbon has an electronegativity value of 2.5 while magnesium has 1.2. So our answer is carbon is partial positive while magnesium is partial positive. Letter F, the last one. Carbon again and fluorine. So as you can see here, carbon has 2.5 while fluorine has 4.0. So therefore, carbon is partial positive while fluorine is partial negative. Let's move on to the last problem, the problem 1.18. In problem 1.18, the question is, order the bonds in the following compounds according to their increasing ionic character. The given are CCl4, MgCl2, TiCl2, and ClO. So let's start with chlorine and carbon. The electronegativity of chlorine and carbon is 3.0 and 2.5, and the difference is 0.5. We just subtract 3.0 and 2.5. Next is the chlorine and the magnesium. We just use the same process. Chlorine electronegativity is 3.0 and magnesium is 1.1. So their difference is 1.8. Next is the chlorine and the titanium, which contains an electronegativity value of 3.0 and 1.1, and their difference is 1.5. Last is the oxygen and chlorine, which contains electronegativity of 3.5 and 3.0. So we subtract 3.5 and 3.0, and their difference is 0.5. And with this arrangement, MgCl2, TiCl3, CCl4, and ClO. That's all for this video, and this is all our answer. I hope it is correct. Thank you.